So let's go back to page 42. So the first one is pretty straightforward, right? If it's a constant, okay? So if it's y equals to a constant, that means the graph is just a horizontal line, right? Y equal to c. So this one, I don't think we need to go over the proof, right? If it's horizontal line, then the slope will always be 0, okay? So remember that if you prime a constant, it will be 0. Now the next one, we can do a quick proof, okay? It's not too difficult. What we are going to use is the definition, the third one, okay? Because the third one is to prove the slope at any point, okay? The third definition says that we have y prime equals to lim h approaching 0 f of x plus h minus f of x over h, right? So in this example we have is the function that we want to prime is a constant times a function, okay? So we are going to use this part and then apply the definition to the new function, okay? To the c times function. C is a constant, okay? So we would have limit h approaching 0. F of x plus h means you sub in x plus h, right? So it'll be c f of x plus h. And then f of x plus h. Sorry, c f of x. Okay, the first part is you subbing x plus h. The second part means you don't subbing anything. You just keep the original function, right? Original function that we want to prime, remember, is this one. Okay, and then O over h. Now because they both have the constant, so I can factor out, right? So I can take out the constant, and then it will look like c f of x plus h minus f of x over h. Is there any questions so far up to this point? All right, and then because this is the way we are going to prove our power rule later, okay? So we use a simple one so you understand what's happening, okay? And then because for the limit law, if you remember from the very beginning, if there's a constant, I can always put it to the front of the limit, right? I can just take the limit of whatever behind. So it will be constant times the limit f of x plus h minus f of x over h. And this part is just f prime, right? It's from the definition of f prime. So therefore, when we prime the original, it will just equal to, so cf of x, the whole thing prime, would just equal to c times f prime of x. Okay, so the constant is not affected because for constant, you can always pull out of the limit, okay? So that's the idea, right? So we're gonna do the similar things to the bottom part. Okay, so we are going to prove if the original function is x to the n, we want to show that it's prime. Its derivative will be n x to the n minus 1. Okay, that's what you've been using for the homework, right? You can pull down the exponent and the exponent minus 1. Okay, so this one is our original function. Okay, So let's apply the definition now, okay? Definition number 3 tells us that if I want to prime, it'll be the limit h approaching 0, f of x plus h. And our function is x to the n, so it will be x plus h to the n, right? Minus x to the n over h. Does anyone have questions about how I set this up? Okay, so because the function is x to the n, right? So we just input the x plus h, and the other part is just the original function. All right, so now from here, this part we need something called the binomial theorem. They used to teach this in grade 12, but they have taken it out, okay? But it's just a formula that we can use whenever you try to expand a binomial. Binomial means two terms, okay? So if I have, for example, a plus b squared, right? Of course, we can expand this very quickly using FOIL, right? Or the formula. But there's another formula that you can use for anything that's much bigger on the exponent, right? Suppose I want to expand to the 20, right? So there's no quick formula for that. So you have to use the binomial theorem. Okay, so we'll use square as an example. So what you need to do is you take the exponent and then write 2c0. C is called combination. Okay, you can find this function on your calculator. And then a, b, the b has an exponent of 2. Sorry, the b has an exponent of 0. A has an exponent of 2. Okay, and then you continue adding. You keep changing the exponent and the number after the c. Okay, keep increasing until it becomes 2. Okay, so going up by 1 each time. Okay, so it'll be 2c1 a b to the 1, and then this part will be 1. So the 2 exponent has to add up to 2. Okay, next one, 2c2 ab2 0. Are you able to see the pattern here? A little bit confusing because you didn't learn this in grade 12. So I'm just throwing this at you as a formula. So let's try another one, okay? So you can see the pattern. So let's say if I want to expand a plus b to the cube now. Okay, so anyone can tell me what will be the first term?
Is it like small 3 and then C0, A to the 3, B0?
Yeah. So you just follow the pattern. It always starts from 0 and then goes up by 1 each time. Okay, so 0, 1, 2, 3, right? So you continue plus, what will be the second term then? Jeffy, do you want to try?
Sure, it'd be 3C, 1,
Yeah.
and then it'd be A2 and B1.
Very good. Okay. Next one. How about Joan? Do you want to try? What's next term?
Sure. So 3C2 and then AB2 and then on the A is a 1.
Yeah, very good. Okay, so the 2 exponents should add up to the original exponent. Okay, the very last term. Nicole, how about you? You look at what's changing, right? 0, 0, right? 1, 1, 2, 2. So what's the next one?
3, 3.
Yep, 3C3, right? And then
A2
it will become A0 now.
and
And
then
then
B3.
B3, yeah, okay? Because the exponent on the second term, it gets bigger and bigger, okay? However, the exponent on the A, it gets smaller, okay? Let me use a green color, right? So you look at the 3, 2, 1, 0, right? So the exponent for A goes down, while the exponent for B, it goes up, okay? So if you simplify this, it will give you the expansion of the cubic, right? So I would like everybody try with take out your calculator, see if we can find the button, okay? The button should look like this, NCR. Okay, if you are able to find it, can you raise your hand? Yeah, Carrie, how about you? Yeah, okay, so let's all try it out, right? So you can just type 3C0, okay? So the 3C0, you should get an answer of 1. Okay, is there anybody who cannot get that?
Wait, what am I supposed to do with the calculator?
So you type 3
Yeah,
and then press that NCR button,
yeah.
right? And then type 0.
3C0.
Yeah.
Okay. And then
So
enter?
hit equal, yeah. Do you get
Oh,
1?
okay, yeah, I see.
Yeah, okay. And then the next, after that is just multiply A cube, and then B to the 0 is 1, right? So we can just leave it like that. Okay, so can you also try 3C1? What do you get for 3C1?
Wait, is the calculator doing Pascal's triangle for us?
Yeah, yeah.
Oh, okay.
Yes, okay. So it's related to Pascal triangle. Yeah.
I got 3.
Yes. Is there anyone who cannot get it? Right? So, and then continue. A squared B, right? What about 3C2? What do you guys?
I got 3 again.
Yeah, 3 again. Okay, so AB squared. And then what about last one? 3C3.
1.
1. Okay, so 1, I can make it invisible, right? Just like the first part. Let's make it invisible. Invisible 1. So that term will be B cubed, right? Because A to the 0 is basically is 1. So here you go, right? You have expanded A plus B to the cube. Okay, so using this method to expand a binomial is called a binomial theorem. So you can apply it to any exponent. Okay, so this is a crash lesson, right? 1 hour lesson in 10 minutes. Okay, talking about the binomial theorem. Okay, because usually we'll explain where that formula come from as well. Okay, so right now just learn how it's applied. And then we're going to use this to the binomial on the left, okay? We have a binomial here, x plus h to the n. Okay, are you ready? So let's write it out, all right? So for the x plus h to the n, I'm gonna use green, okay? So you can see more clear, right? So that part, the first term will be nc0, right? Because we don't know the n, we just write n. And then x to the n, right? Because n minus 0. And then h to the 0. Make sense, right? You compare with the example on the left, on the right side. If it's cube, then you have a cube. right? And then starting from there, it goes down, right? And then the red part, it starts from 0 and go up, okay? We are just following the example. Now, what about the next term? Let's see. Carrie, do you want to try? How do we write out the second term now?
I'm a little confused about this whole binomial theorem thing.
Okay, which part you feel confused?
How we turn like the x to the power of n into like the binomial theorem.
Okay, don't look at the left side yet. Don't look at the x. Try to, like, do you have question about the thing in the red box right now?
No, I get it. Like I get the pattern and everything.
Mm-hmm. Yeah, the pattern, you get it. So is it the why we use this that you're confused?
I guess so.
Okay, so this, the theorem is to help us expand the terms, right? Instead of doing FOIL, right, or distribution, we can get the final answer directly without expanding. So A can be anything, right? A, it just represents the first term. B represent the second term. Okay, so instead of A and B, we have X and H. We are just changing the letter, that's all, and then doing the same thing. Does that help you?
Yeah.
Okay, and then instead of having an exponent of 3, what do we have?
An exponent of n.
Yeah, and then we're just doing the same pattern, write out the expansion, that's all. Make sense?
Yeah.
Okay, so if we apply the same pattern, how do you write out this next term now?
Would it be like the same as the first one, except there wouldn't be an h?
There will be H still, right? The pattern, right, for the C, right, you start with NC0. So the next one should be NC what? If you look at the
1.
pattern, yeah, right, because it goes up, right? And then the exponent for the first term, it should go down. So it will become N minus 1, right?
Oh, okay.
And then the exponent for the H, it will go up. So it will become
1.
1, yeah, that's all, right? We are applying the same pattern, except right now is they are all letters, that's all.
Oh, okay, that makes so much sense.
Okay,
Thanks, Jason.
yeah, you're welcome. Okay, and then let's do one more term, okay? So how about Leon? Do you have any questions?
No, I don't have any questions.
Okay, so can you tell me what the next term look like?
Okay, it would be NC2
Yeah,
x to the power of n minus 2
excellent.
and H2, right?
Yes. Yeah, very good. Okay, plus dot dot dot. Of course, it will go on for a long time, depending on how big the n is, right? If n is 3, it will end as 3C3, right? So if n is just n, right? If it's just n, where do we stop then? What will be the last term look like? Lex, you want to try? How do we write out the last term?
That would be n.
I can't hear you anymore.
N C N
Yeah,
X
yeah,
0
very good.
H N.
Yes, okay, perfect. All right, so this part will be the expansion of the first section, okay? And then we are going to minus x to the n. O over h. Okay? So don't forget our purpose here, right? We are trying to find the derivative. That's why we sub into the definition and then do the expansion. Now, what we need to do is to simplify this expression. So please take out your calculator Well, actually, we couldn't take out because we have n, right? We couldn't use calculator. So we're gonna just use the example on the right side to help us simplify, okay? So the ones on the top, okay, let's look at the first one. The 3C0, it turns out to be 1, right? If you try it out other ones, if it's like 5C0, you can try with the calculator, it will also be, right? 7C0 always be 1, okay? So NC0, it will also be equal to 1. And then x to the n. H to 0 is just 1, right? So I'm gonna just leave it blank. Now let's look at NC1. So if you look at next one, 3C1 will be 3. Okay, if you try with the calculator as well, 5C1 will be 5, 7C1 will be 7. It'll be the same number as if it's 1. Okay, so NC1, it will just be n. Right, 3C1 will be 3, so NC1 will be n, all right? And then x to the n minus 1 times h. Now NC2, I'm just gonna leave it as NC2. NC2 will be more difficult to find the answer, okay? The C0 and C1 are the easy ones. Okay, so just leave it like that. Now the last one, NCN. So if you look at the example now, 3C3, that one is also equal to 1. Okay, 5C5, we can try it later, right? 5C5 will be 1. So the last term will also have a 1. Okay, so 1. X to the 0 will be 1 as well. So I'll just leave it as h to the n, right? Close the bracket. Minus x to the n. Is there any part you have questions? Can you ask me? Are we good? Okay. Now the meaning of NC0, NC1, it's about combination, okay? Number of combination, number of ways you can choose items, okay? So that will be another course, right? When, which you used to be in the curriculum, okay? But then right now you just apply the calculator, okay? All right, so next part is we can see something can be canceled out in the numerator. Which ones can be canceled out here? Anyone? Do you see anything we can cancel out?
xn and xn.
Yes, okay. The very first term cancels each other out, right? And the last term. Now, if we try to sub in 0, it will give you 0, right? Put 0 into h, it will get 0 on the top, 0 at the bottom. So it's still indeterminate. So we can start by dividing the h. Each of the term divide by h, right? H divide by h, right? Square divide by the h. This one will become n minus 1. Any questions so far? It's the same as you factor the h out and cancel the bottom, right? Or I can just divide each term by the h in the denominator. All right, so once we cancel that out, now we try to sub in the 0. Then the terms that still has the h will be gone, right? Everything in the middle will be gone. This one will also be gone, right? Because those terms are the terms that has h still. The only term that's left is this one, right? Because that one, after you divide it by h, no more h, so it will stay. So finally, you get n x to the n minus 1. So this is your final result. Okay, so that's why you have this formula. Okay, this is called the power rule. Okay, I only chose to prove this one because this one is very important. Okay, you use that all the time. Okay, I just feel bad that you just get the formula and then without knowing where it's come from, okay? So if you see a polynomial and it also helps you remember, right? You just apply the formula, it finds the slope at any place, okay? All right, so if no question, we're gonna move on, okay? Now you just need to know how to apply it properly, right? And make sure your notation after prime and before prime, make sure you don't put the prime too quickly, okay? So today we're gonna learn the next rule. Last time we stopped at product rule, right? Today we're gonna add in a quotient rule. So quotient rule looks very similar to product rule, right? If you look at the top, they just take turn, right? Each one by one, f prime g, f g prime. And then instead of adding, we have a subtraction. Now the extra stuff that you have is the g squared at the bottom, okay? That's the only thing. So we'll try to apply that. Now the example we have here is d bracket, okay? What does d means? It's just find the derivatives. It's same as d dx, okay? Find the derivative of our function. So this is the function, okay? So you can look at this as the top is the f, the denominator is the g, okay? So derivative of this function, you just apply the formula, f prime, okay? So what is f prime, John?
F prime would be 2x.
Yes, okay, so f prime and then g is stays, so I will just copy it. And remember, quotient rule, it has to be subtract, okay? Subtract by f, g prime, okay? What is g prime, Leon?
It would be 2x. Hold on, let me read it.
Yeah.
2x minus 0.
Yes, okay, so the 0, I will just skip it, right?
Right.
And then O over g squared. So I'm just copy the g and then square that, okay? And of course, this one we can simplify very quickly, okay? The denominator, you don't need to expand, okay? Because it's short enough. Usually we want to keep expression as short as possible, right? Now the top, we can simplify by expanding it. Okay, multiply those two together. So you get 2x cubed minus 8x minus 3x, sorry, 2x cubed. Okay, so that cancels out, right? These two are gone. So you're just left with negative 8x over x squared minus 4 squared. Okay, so this expression that you get, it represents the slope at any x. Okay, the slope of tangent at any x value. Any questions so far? Okay, so that's you once you know the rule, it's the rest is just algebra. You just plug it in into the right place. Okay, there's not much thinking involved. Okay, so now I would like you to try question C. All right, apply the quotient rule. So once you finish C, please raise your hand. Okay, we'll check the answers together. So remember, watch out for your notation, okay? Do not start by writing equals to and then prime, right? You have to write a new title, f prime of x equals, okay? And usually the common mistake or careless mistake it happens when you have subtraction. Okay, so watch out for the sign. Okay, it might affect some sign as you work through it. Please raise your hand if you have final answer. Make sure you simplify. Just simplify the numerator. Okay, let's see. Emily, what's your final answer?
I have x squared plus 6x. Wait, jokes, I did something wrong.
Hmm?
Give me a moment.
Okay.
X squared plus 6x minus 1. I think. All over x plus 3 squared.
Okay. Anyone get different? Leon, what do you have?
I have the same thing.
Same thing. Nicole, any questions?
Oh, I'm still doing it.
Okay. Right. I'll write down the first step. Okay. So if you get something different, you can check which step you got wrong. Okay. So f prime g minus f g prime, right? Over g squared. Now after that, you just expand the numerator. Okay, so that looks like 2x squared minus x squared. Yeah, that looks good. Okay, so it should be fine. Okay, plus 6x minus 1. Okay, so we are all good. Let's try the question D now. Yeah. So please raise your hand if you finish D. This one, the algebra might be a bit harder, right? Okay, anyone has questions? Okay, Jeffy, what's your answer look like? Jeffy?
I'm sorry, did you say Jeffy or Jesse?
Jeffy.
Oh, my bad. Root x minus half root x over root x.
You mean all over?
Yeah. And then for it's minus half and then root x.
Oh, okay. Root x minus half root x.
Yeah.
Okay. That means they are like terms, right?
Oh wait, yeah.
Then I can simplify more.
Yeah, my bad.
So
It would just be wait, my brain is blanking. Wait, negative 3 over 2 root x? Wait, I don't think he's straight right now.
okay, I'll leave it to you. Okay, tell me when you got it. Okay, how about Carrie? What do you have?
Can I double check mine? I think I got like one of the signs wrong.
Okay. Leon, how about you? What's your answer?
I'm not really sure. I probably messed up, but I got 1 over 2 root x.
Root x is on the top or bottom?
Root x is on the bottom.
Okay, so like this. Okay. Jesse?
I just got 1 over 2 root x.
So same as Leon?
Yeah.
Okay.
Wait, is it legal if I split it into x over root x plus root x over x and then simplify and then
Yeah.
find derivative?
Of course, yeah, you can rewrite it, right?
Right.
Here, or you can apply the quotient rule, right?
Oh, yeah.
Okay, so this one, probably most of you just apply the quotient rule. So like Jesse said, right, maybe in some cases, if you can rewrite it and make it look simpler, right, then we can get the answer without the quotient rule, if possible, right? Sometimes it's impossible to do it without quotient rule. Okay, so let's try, okay? See, so Jeffy, how about, have you got a new answer?
I got 1 over 2, but I don't think that's right. I think I messed up somewhere.
Over 2.
I got the same thing as like the 1 over 2 root x.
Okay, right. So Jeffy, your variable disappeared.
Yeah, because I could get rid of the root x from top and bottom.
Okay, all right. So root x cancel out. All right, so let's check these steps, okay, for the quotient rule. So f prime. So Jeffy, what do you have for the f prime?
I got, wait, give me a second. 1 plus half x, exponent negative half.
Yeah, very good. Okay, times it by g, so it'll be x to the half minus, okay, f. So f stay the same. G prime, what is g prime, Jeffy?
Half x,
Mm-hmm.
and then exponent negative half.
Yep. So far, so good. Okay. And then over g squared. What will be the g squared, Jeffy?
X to the power half.
But then you will have to square it, right?
Yep.
So cancel out the half. Okay. All right. Now, after that, we can try to simplify this, right? So we're going to expand this, right? One by one, slowly. Okay. So x to the half times 1 will be x to the half. And then when you multiply the same base, you need to add an exponent. So negative half will add with the half, right? The exponent on the x, these two will add when we multiply in. So they actually cancel out, become x to 0. So you just end up with half. Okay, and then minus, second part, similar, right? This is x to the 1, so you need to add an exponent. It will become half x to the 1/2, okay? 1 minus half will be half. Plus half, and then x canceled out again, okay? Because the exponents are opposite sign. And then denominator will be x to the 1, okay? Half times 2 will be 1.
Oh, I know what I did wrong. I forgot to carry the exponent 2 down to the next line. Yeah.
Right. Okay, so now after this, let's take a look what can be canceled out on the top now. Okay, Joan, how do we simplify the numerator now?
So once you expand the brackets,
Mhm.
you see the x to the power of a half, and then you just take 1 minus half of that, so you just have a half x to the power of a half.
Half x to 1/2, okay, and then
The halves cancel out
the half cancels out, yeah, and then
all over x.
over x, okay, and then we simplify that. When we divide, you subtract the exponent, so it'll be half x to the negative half, okay, which simplifies into 1/2 root x. So this will be a long way to go, but it's a good practice to use for practicing the quotient rule, right? Just checking your algebra carefully, right? With all the fraction and the exponent, that's difficult, right? But then, like Jesse said, if you stop and look, right? Look at the function before we apply the quotient rule right away, right? We could rewrite. Just like in your homework, when you rewrite, do not start by writing f prime. You have to still keep f of x. So we can rewrite this by splitting the fraction. And you can only do that if the denominator only has one term, okay? Like question C, you cannot split the fraction because you got two terms, okay? So you cannot just split x over x and then over 3, right? So x plus 3 is stuck together. So look at question D. If we split, the first term will be x over root x. Second term will be 1, because root x over root x is just 1, okay? And then I'm going to simplify even more. What does x divide by root x? Can we simplify that? Emily? How can we simplify x over root x?
X over what?
X over root x. Can you help us simplify that?
You can put it into the exponents and
Yep.
then minus, subtract them, subtract
right.
them.
Yep, so what would you end up with?
X to the negative half.
Why?
Pardon?
Why is that? What's the exponent on the top?
Because you have root x, so it's x to the half, and then you have x on the bottom.
X.
So it
X
would be
is at the
half
top, though.
minus 1, right?
But x is on the top, not at the bottom.
Oh, sorry, I thought it was on the bottom. Then you would have x to the half.
Yeah. So it'll be x to the half plus 1. Yeah.
Mm-hmm.
Okay. We are looking at the right side. Right now we are rewriting. Okay. And then once you rewrite it, it becomes something that doesn't require quotient rule. And you do the prime. Okay. Then that will end up much faster. Plus 1 when you prime will be 0. Right. So these two ways, right, telling you that sometimes you can stop and look, right, see if there's a easier way to simplify the question instead of just throw into the quotient rule every time, right? Because quotient rule, we only use it if necessary, right? Okay, so let's try the next question. The next question, don't want you to simplify. I just want you to apply the quotient rule and then just leave it as it is, okay? Do the first step, okay? And then as you can see here, inside the quotient, there's a product. So this is a good practice for you to think about how we can apply the product rule while using the quotient rule. Okay, I'll rephrase that. The big direction is quotient rule here, right? Because you see a quotient. So this is the F, this is the G. But then as you are applying the quotient rule, when you do F prime is a product. So you need to also apply the product rule as you go along. Okay, so you don't need to get to the final step, okay? I just want you to try applying the product and quotient at the same time, okay? See if you get the concept correct. All right, so once you finish the first line, you can raise your hand, okay? There'll be a longer, much longer numerator. Remember, for this question, you don't need to simplify, okay? Just apply the rule, that's all. Just do the first step. Then you can raise your hand. Okay, I will do the hardest part for you. G squared. Any question, Jeffy, Leon, and Nicole? Doing good? Okay, Carrie, can you tell us your first part?
I got bracket
Mm-hmm.
x minus 1,
X minus 1.
bracket minus bracket x plus 1, and bracket. Oh wait, there should be a minus between those two brackets, I think.
The first two?
Yeah, and
Okay.
then multiplied by bracket 2x minus 1, and then multiplied by bracket x minus 1, and then subtract bracket x squared minus x minus 1.
Can you say one more time? Minus.
Bracket x squared minus x minus 1.
Mm-hmm.
That's it.
And then,
Um,
is that all?
yeah, that's what I got.
Okay. Anyone else? How about Joan?
I'm kind of checking what I'm doing, but wait, let me keep looking real quick.
Mm-hmm.
Wait, Jason,
Yeah.
when you said product rule, I thought you meant multiply them together first.
No, we're not multiplying. We're keeping the way it is.
Oh, okay. Then I have to redo this. Never mind.
Yeah. So do not do any expansion, right? No rewriting at all. So this is the practice I want you to try, right? Applying product rule while you are doing quotient rule, right? Because inside the quotient, we also see a product in the numerator, right?
Yeah.
Because sometimes you might see a question like this, like sine x. Later we'll be learning trick, right? Sine x and then cosine x, and then over, let's say, log x. I'm just making something up, right? So it's like three things here. So this you cannot expand it, right? So you just have to deal with what you have.
Oh, okay.
Yeah. Okay. And Joan, have you figured out yours?
Or I'm just gonna say my answer, but I'm
Just say your answer.
sure. Yeah, okay. So I got like I did square brackets to like keep stuff in brackets.
Okay, so square bracket.
And then bracket x squared minus x minus 1.
Mm-hmm.
And there should be a bracket 1 next to it, but I just left it how it is because it's just the same thing anyways. And then plus bracket x plus 1.
Yeah.
And then close bracket, another bracket 2x minus 1.
Mm-hmm.
And then end of square bracket.
Mm-hmm.
And all of that times x minus 1.
Mm-hmm.
And then minus, and then square bracket, bracket x plus 1,
Mm-hmm.
bracket, and then bracket x squared minus x minus 1.
Mm-hmm.
And then, yeah, that's done. And then all over x minus 1 together squared.
Oh, so all over like that.
Yeah.
So x minus 1 squared. Okay, so we have two so far. Okay, I won't collect too much answer. Okay, I'm running out of space. So I have two different answers here. It doesn't matter if you get it right or wrong. It's not a competition, right? I just want to see like which part you usually make the mistake. Okay, so I will now show how I would do it. Okay, and then you can compare. All right, so I'm gonna use different color so you can see more clearly, right? So our big direction is the quotient rule. So quotient rule will be f prime and then g, right? And then minus f g prime, right? We'll just write down the general structure of it, right? All over G squared, right? This is the format, what it should look like. So the first big bracket is F prime, but then the F has two things. So that means when you are doing the first big bracket, you need to apply the product rule, right? So this is like the F inside the F. This is like the G inside the F, right? Because it's a product. Okay, so we're gonna apply the product rule. So that will be F prime, that will give you 1. G. So that's F prime G. Product is always adding, right? So plus F G prime. G prime will be priming the, remember we are focusing on the green now. So G prime will be 2x minus 1. Okay, so that's the, so far we only finished the F prime for the quotient. Okay, and then times it by G, so G stay the same. So it will be x minus 1. Okay, minus F, so we just copy whatever on the numerator. So x plus 1 times x squared minus x minus 1. That's called the F. Times it by G prime. So G prime means the denominator part, right? G prime of that is 1. Okay, and then all over G squared. Okay, a lot of thinking here. You have to keep your head very clear, right? And
Hey,
then
Jason.
not sleepy. Yeah. Question.
Wait. I don't really get the top part. I get the bottom x minus 1 squared, but the top part, I'm like kind of confused because we have like,
Which
we have like it's like f prime g minus f g prime, right?
Yeah, the red bracket is the f prime g minus f g prime. And then the green part, the whole green part is about the numerator prime, which needs product rule. So the green part is showing the product rule. Do you see it?
Oh, yeah. I get it.
Get it now?
Yeah.
Okay. Yeah. So of course after this, right? If the question requires you to expand and simplify, then you do your FOIL carefully, right? Just watch out for the subtraction. Okay. Yeah. Right. So this idea, right? This concept, you make sure it could happen, right? Later on, you could see something like the question on the top right corner, right? Which you cannot expand. Otherwise, right, if you see question like this in the homework, it will be easier if you expand the top first, right? Make it into a single polynomial and then just do the quotient rule. Okay, but this is a good practice, right? All right, so any questions about this one? Okay, this is a mix of product and quotient rule. All right, so what's the point of learning these rules? The point is to get a slope, right? Because everything we've been doing is try to find the slope of tangent. Except now we can find it without using limit, okay? So here, let's try a simple example. Please find the slope of tangent at x equal to 4, okay? So first, you need to find the slope at any point using the rule that you've learned so far. After that, right, this means slope at x equal to 4, then the symbol is just prime of 4. Okay, you just plug the 4 into whatever you got in your step 1. Okay, so I'll let you finish this part. This is not difficult. Okay, when you finish, please raise your hand.
Wait, Jason, just to double check, the green part of the last one, that's like the entire top f prime, right?
Yes.
Oh, okay, yeah.
Yeah, because the entire top, you need product rule to carry out.
Yeah. But then I also have to find the prime of the entire thing too.
Prime of the entire thing.
Like the entire,
the,
the entire green part.
yeah, because
Okay.
the entire top is a product. So to prime that, you need to use product rule to accomplish.
Okay.
Right?
Thank you.
Yep. Okay, let's check answers. Okay, Leon, what's your final answer?
I'm not sure if I did right, but I think I got -3.
-3. Okay, Nicole, how about you?
I got -7. I might be wrong.
Okay, Carrie?
I also got -3, but I want to double check my work.
Okay, Jeffy?
-4.
Okay, Emily?
I have -7, I think.
Okay. Oh, about even, eh? Okay, so probably some common mistake happening here. Lex?
-7.
Okay. Jesse?
I have -7 as well.
Okay, so feels like -7 is the one. All right. So let's go through the steps then. Okay, Joan, can you tell me your f prime of x? How do you prime this?
I just used the just the rules. I don't really know which one, but like in the end, I got -2x plus 2x to the power of -12.
Okay, yeah, that's good. Okay, power rule. Okay, you just apply power rule to both.
That's what it's called.
Okay, and then after that, we just plug in the 4, right? So it should be pretty straightforward. Any question about the prime? Okay, we just plug it in now. -2 times 4 plus 2 times 4 to the -12. That's it, right? And simplify it, that would be -8. 4 to the -12 is 1 over root 4, right? So that's like 1 over 2. So that should end up with -7. Okay, so may I know what which step you did wrong, Jeffy?
I just forgot it was -12 for the exponent. So I
Okay.
don't. Yeah, I just put it as root x instead of doing it over root x.
Okay. You know how to get the negative half, right?
Yeah, I just did it. I got it.
Okay. How about Leon? What did you do?
Oh, I think for the first part, for the x to the power of negative half, I just wrote it at the bottom.
Wrote it at the bottom. You mean?
So it would be like the numerator over root x.
Numerator over root x. What do you mean? So 4 over root x?
No, I wrote negative 2x plus 2 over root x.
Negative 2x plus 2 over root x. Well, that's the same.
Oh, I mean I did the whole thing over root x.
Oh, okay.
Yeah, it's a little mistake.
Big denominator. Is it like that?
Yeah.
Okay, I see. Yeah. So because these two are separate terms, right? So you would, yeah. So the denominator only goes for the second term. All right. So the next one, I put a challenge there, right? Jesse, have you tried it?
I was like kind of confused because like the place where you gave us like to draw the parabola, so I drew the parabola x squared plus 1, and then I plotted the point 0, -1, and then I tried to draw like a line connecting that like touched the parabola. But then I didn't really know how I was supposed to find it, so like I did like like what's it called, derivative, or like the prime of x squared plus 1, and I got 2x.
Yeah.
So then I did y minus 0 equals, oh no, y plus 1 equals plus minus 2, and then bracket x, just x. And then so then I got 2x minus 1 as one of them, and then negative 2x minus 1 as the other.
Okay.
But I don't think I did it right.
Okay. Yeah. We'll explain what's the flaw in that step. Okay. Yeah, we'll get there. All right. So compare these two questions. I put these two next to each other for a reason. Okay, because these two, they look very similar, right? They both give you a function. Right? They give you the question 3, they give you a parabola, right? Question 2, they also give you some function, which I don't know what that looks like, right? And then question 3 asks you to find the equation of tangent. So equation of tangent means you need to know the slope, right? You also need to have a point, so you can write a point slope form. So it's the same as asking you to find slope. Question 2 also asks you to find slope, right? So they are basically asking the same thing. And then question 2, tangent to the graph at x equal to 4. That means the 4 is on the graph, right? Because you want to place the tangent line touching the function, right, at 4. So let's say here's the curve, right? And then you place a tangent line, let's say here. This point has x equal to 4, okay? And y we don't know, okay? The y value we don't know. It's just the x is 4, right? Now for the next question, it also gives you a point, all right? But I want to know if this point is also on the graph or not, right? 4 was on the graph. What about 0, -1? Is 0, -1 on the graph?
No.
No, right? How do you know? How do you check without graphing?
If you plug in the point 0 into x squared plus 1,
Yeah.
then your answer is +1, not -1.
Yeah, okay. So if you plug in 0, it doesn't match the point. So that means this point is not on the graph, not on f of x. Okay, so that's the biggest difference between the two. They both give you the function. They both give you a point, but the first one, the question to the point, is on the graph, okay? On f of x. Okay, the second question, the question 3, is not on the function. So that's why you cannot do the same way, right? So if you plug in the 0, then the slope that you get is not the slope of tangent, right? Because it's not even on the graph. Make sense? Okay, so for this one, let's draw it out, okay? See what it looks like first. So this is a parabola with a vertex at 0, 1, right? So let's draw that. And then opens up. And then they give you a point that's at 0, -1. So 0, -1 will be here. It wants you to find the equation of the two tangent, right? Both. Two tangent line that touches the parabola at the same time pass through 0, -1. So the passing through is for the tangent line. Okay, it's not for the parabola. It's not same parabola that pass through 0, -1. Okay, you want to find the tangent that passes through 0, -1. So why are there two tangent lines? Can you help me draw it? Anyone wants to draw? What does it look like? Two tangent lines. Yep.
Okay, it's not very straight, but you kind of get the idea.
Yeah, pretty good. There's one. Yeah, okay, there's another one, right? So it's a symmetrical one, right? So left and right should be opposites, like one positive slope, one negative slope, okay? Right, so let's clear this drawing. Right, so here's one tangent line. So touches here. The other one should be touching the same place. Okay, so two tangent lines. Now let's think about what Jesse did, and then how come? Because it's common things to do, right? How come that way the thinking doesn't work, right? So you primed it, right? So y prime is 2x, and then what did you do?
I didn't know what to do, but I knew that it was symmetrical, so there's going to be a plus minus 2.
Yeah.
And then I try to put in.
Hold on.
Sorry.
Where's the plus minus 2 come from?
Oh, because it's symmetrical. The equation of the tangent lines, because the parabola is symmetrical, which means the tangent line is symmetrical too.
Yeah, yeah. And then?
Yeah, so then I kind of plugged in 0, -1, but I was like kind of confused because it's not even a point on the graph. So I was like, am I doing this right?
Okay, so, but then you don't have the slope, right?
Oh, I see what you mean. Do I have to plug it into, wait, what? Isn't two the slope of the line?
No.
No?
Because this, after you prime, this represent, what's the meaning of that?
The secant line? Wait, what?
Oh, this is a prime. Okay.
Yeah.
Anyone answer this question? What, after you prime, what does this expression mean?
Oh.
Yeah.
Is that any x?
The what at any x?
The slope of
The
tangent.
slope.
Yeah. So it's the slope at any x value. Okay.
Wait, but then wouldn't my isn't okay, but then if my slope, if the point is 0, -1, isn't my slope 0?
Well, if slope will be 0, if you plug in 0, then that's saying that's finding the slope. I'm gonna draw it out, okay, with the blue.
Okay.
That's finding the slope of this line.
Oh yeah.
Touching 0, right?
Okay.
Yeah. So right now, right, this 2x is not saying the slope of the tangent line is 2. Make sense? Yeah.
Oh yeah, I see it now.
Okay.
Yeah, I get it.
That's why every time after I prime, I keep repeating what does it mean, right? It represents slope at any x, all right? So the 2 is not a slope, okay? So here we see the trouble, right? We don't even know the slope, because if we want to find the slope, we need to know where it's touching, right? Where the tangent point is, right? Where this point is. Only if I know the point there, then I can plug in the value, then find the slope at that place, okay? So that's what makes it difficult right now. So here I'm gonna write out the steps, okay? How to do this one. Okay. All right, so let's go to here, okay? Go to the right side. So first, we are going to let, because right now we know the difficult part is not knowing the tangent point, right? So we're gonna let the tangent point be AB. Okay, so we need to figure out what A and B is first. If we know where the AB is, then this become an easy question, like question 2. Okay, so after that, okay, then we'll put that into the picture now. So this will be AB. Okay, and then we'll go back.
Wait, Jason?
Yeah.
The one on the left-hand side, is it AB or is it negative AB?
It will be AB.
Still?
So there will be 2 values of A.
Oh, okay.
Yes. Yeah. So as
How come we don't put negative AB? Because isn't it quadrant 2?
Yeah, it will be quadrant 2, but then when you find the answer for A, it will come out 2 possibility.
Oh, okay, okay.
Okay. Yeah. So now step 2 is we are going to find the slope of tangent by derivative. Okay, since you just learned it, right? So which Jesse already did, right? We find the slope y prime equals to 2x, right? We prime the parabola, right? It finds the slope at any x. Okay, but then I'm interested in the slope at AB, right? So find the slope of tangent by derivative at AB. So I'm going to sub in A. So the prime of A will be 2A. So this is the slope at AB. Any questions so far? Okay, so far you don't know the value yet. All you know is an expression. Okay. Right, now question 3, we're gonna borrow something you learn in grade 10 when you learn about finding slope, right? So we will also find the slope of tangent again, okay, but then this time is by rise over run. So delta y over delta x. So 2 different ways to get slope. One is using calculus, one is using rise over run. Okay, how do we find the slope using rise over run?
Wait, would we use the point 0, -1?
Okay, is that point on the line, on the tangent line?
Yeah, because it has to pass through.
Yes, then you can, right? So you need 2 points to find the rise over run. Okay, so let's do that. So rise over run. Okay, what goes on the numerator now? How do we get delta y?
Would it be b plus 1
Yeah.
over x?
No.
Oh wait, sorry, a.
Yes, a minus 0, okay? So we are using the tangent point and the other point, and then we do the rise over run, okay? So which we simplify it into b plus 1 over a. All right? So this is also the slope. So we found the slope using derivative. We also found the slope using rise over run.
Wait.
Do you think they will be the same?
Yeah. Wait,
Yeah.
do we just make them equal to each other?
Yes, and then we're gonna make them equal, okay? So because they are both talking about the same thing, just doing it differently. So 2a should equal to b plus 1 over a. Okay, so we have one equation right now, right? With two unknowns. What else do we need?
Another equation.
Another equation, right? So you can get a system of equation, right? Two unknowns, you need two equations. So where are we gonna get a second equation? Anyone?
Negative 2a.
No. A is going to be two different values.
Oh.
Yeah.
Maybe from B?
From B? What do you mean from B?
Like if you tried to figure out B?
We are figuring out A and B at the same time. The hint is to look at step 1.
Wait, Jason.
Yes, Jeffy?
1 over a only for like the positive slope. So if you just made that negative, would it be another one for like just
A and B, they are unknowns, right? So A could be
Oh,
positive.
right. Yeah, okay.
Yeah. So
Yeah.
A, B represent all the points, all the tangent points. Okay, the hint is look at step 1. How can we get another equation from step 1? We know the tangent point is AB. So AB must be on which graph?
Jason,
Yes?
can you plug AB into the parabola, like the function?
Okay, can we? Is it on the parabola?
See?
Okay, so we can plug it in, right? So that's something we can use. So B will equal to a squared plus 1. There we go. Very good. Okay. So there we have two equations with two unknowns. Then we are able to solve it, right?
Senior?
Yeah.
Can we make the first one 2a squared equals b plus 1? Because the second one already has a squared, so it's easier to eliminate.
Yeah, you can, you mean cross multiply over, right?
Yeah.
Sure. Yeah, okay, so I'll let you do the rest, right? So from here, step 4, right? We can write solve the system. Okay, but you can make a note. This one comes from slopes. Okay, how about we write it like this? The first equation comes from number 2 equal to number 3. The second equation comes from AB into y equal x squared plus 1. Okay, make a note, right? Because for your homework, I'll be giving you one question similar to this. Okay, so I'll let you solve the AB now. And then once you get the answer for AB, please raise your hand.
Hey, Jason, I don't know if I did it right. Do I still raise my hand?
You still, do you have an answer?
Kind of.
You have 2 points?
Yeah.
Are they symmetrical?
Yeah, the A is plus minus.
Yeah, yeah.
And then the B is just B.
Yeah. Because math cannot lie, right?
Yeah.
Okay.
Except I don't know if my A is right.
Okay. Yeah, you can put up your hand. Emily, what's your answer?
So I don't know if I'm right, but for me, A is plus minus root 2, and then B is 3 and negative 1.
3. Oh, B, but B should be the same though. You have two different B's?
Wait. Oh.
Because
I have two A's, right? So if you plug in one with plus minus, right?
But it should still end up with the only, that should be.
Oh, wait, it would be 3. It would be 3. Sorry, don't listen to me. It's not negative 1. Don't listen to me.
Esty, how about you?
Oh, wait. I saw something I did wrong.
Okay.
Sorry.
Yeah, it's okay. Terry, what's yours?
I got plus minus root 2 and 3.
Okay.
Oh yeah, that's what I have too.
How about you, Lex?
I've got plus minus root 2 and 3.
Okay. Okay, feels like that's the point. Please raise your hand, okay, if you are able to get plus minus root 2 and 3. Okay, I'm gonna carry out the steps here. Okay, so for, like Jesse said, we could cross multiply the a to the left. You get 2a squared equal b plus 1. And then plug in the a squared, or plug in b, right? So 2a squared equals to a squared plus 1 plus 1. Okay, and then from here you can solve for a squared. A squared will be 2. A will be plus minus root 2. And then you go back and plug into the second equation. Then you get b equals to 3. Any question, Nicole?
Oh, no, I forgot to raise my hand.
Oh, okay. Right, so that's the point, right? Once you get the point, then of course you can do what? What's our goal here? What do we do now? We're almost done here. What's next step? What's the point of finding AB then?
Wait, can we find, if we have the point, we can find the actual equation, right?
Yeah, and then to get the equation, you now need to figure out the what?
Slope.
Yes, okay, so let's get the slope. To find the slope, how do we do that, Jeffy?
Let's do root 2. Wait.
Yeah.
Oh yeah, root 2 over 4.
How'd you get that?
Like, cause my first point is root 2, 3, and my next point is 0, -1.
Oh, so you're using the delta y over delta x?
Yeah, I like that one better.
Okay. How about step 2? What does it say in step 2?
Oh shoot, you're right.
Right? Much faster, right?
Yeah.
Slope is just 2a.
Yeah.
So from here, you just have plus minus 2
2.
root 8. Sorry, 2 root 2. Yeah. Okay. And then we can write out our equation. Let's leave it in point slope form. Okay. So write out your equation, and then you can raise your hand. Just point slope form. You need to pick a point and then apply the slope. Okay, Leon, which point did you pick?
0, 0, -1.
Okay, so how do you write out the point slope form?
Oh, I'm still writing it right now.
Okay, let me know when you have it.
Is point slope form the one where it's like a y equal mx plus b?
No, the one with y minus something.
Oh, okay, I got it.
Yeah. Okay, so can you tell me?
Y plus 1 equal to two root 2, sorry. Bracket x, and then the second one would just be the same thing but with a negative slope.
Yeah, okay, so plus minus. Okay, so you can leave your answer like that, right? Unless they say, please write out slope y-intercept, right? You can check answers. Sometimes they leave it in different forms. Okay, let's have a break. And if you have questions about any steps here, basically the key step is this one, right? How to make the equations, right? So you can stay during the break and ask me, and I'll see you at 6:55.
Yeah, thank you.
Yeah, you're welcome.